Good day. I am Professor Timothy Kentop at the University of the Virgin Islands. Today we're going to investigate first steps you may take to collect additional information about unusual events that are going on your PC or your laptop. If you notice that things are running slow, you suspect you've been infected with malware, or that it's been hacked, or you have spyware on there. Even free software has a lot of unwanted network activities. So the important thing is to use some simple tools to collect some information, and then from there you can use this information to investigate further with other tools like sysinternals or Wireshark. First, before we get into the tools, I'd like to review a bit about network connections. So essentially, the common model that's used for a session out on the internet when two devices or systems are connected is the client-server model. So you'd have a server that operates on a well-known port, usually a lower number, anywhere from 0 to 1023. So a server is going to run an application or a service, and it's going to be listening for a connection so that it can provide resources or data to clients. And there are registered ports with well-known applications designated. Usually these are lower numbered ports, 0 to 123. You often find these running on servers. It's often confusing to most that laptops and PCs can function in the role of a server. They can be running a service or a process that's ready to connect. It's listening on a port, and it's going to provide resources and data to others out on the internet. In that case, even though you would consider a laptop or a PC to be a client machine, it's the role we're talking about, not the type of classification of hardware. That's an important distinction. In any case, the public IP address of that resource and the registered server or application port together combined is 1/2 of the connection or session. The other half of that connection, which when combined with the client side is called a socket, that's usually a much higher number. So the client computer, the computer that's going to request a connection or a session for the system that's running a service or process and listening on a port, the client is going to use what's called an ephemeral port number, a very high numbered port. It's random for each case, for each session, even using the same application. So if you have 6 tabs open on Google, there are 6 connections to 6 different websites, and each one of them has a different port number, an ephemeral port number. So this is the client side of the connection. The client IP address in combination with the ephemeral service port is used on the client side, and together the two of them create this convention known as a socket. So when a session or a connection is formed, basically a socket, a network socket is built. In this case, you see we have, this is just a quick example, if we had a server, we had something that was running a service or a process, and it was listening for a connection. It could be listening on port 80. That's a well-known web server port, or 443, that's HTTPS. And in combination with the public IP address, that's the server side, here's the client side. It's important to understand how to recognize these. There are exceptions to the 0 to 1023 registered ports. There are some higher numbered ports, like SQL, for example, uses 1434. So there are some exceptions to the low numbered ports, but generally a very high 5-digit number that tends to indicate client side. Anything well beyond 1023 tends to indicate the client side of the connection. Anything that's in a well-recognized registered port range would tend to identify the server side. In any case, you can have multiple clients using the same public IP address. For example, when you have a home router and they all have one single public IP address, if you're connecting to the same website, each of those clients can have different port numbers that are formed for their connections, their sessions, and in that way the socket is different. So the server can distinguish between the separate sessions that are formed. In any case, what we're going to do is look at both sides of these coins, because your laptop or your PC could function both as a server, meaning it's running a service or a process, and it's listening on a port for a connection from someone, a foreign host, right? Or it could be participating in connections out on the internet with foreign hosts that are functioning as a server on their side, and your laptop or your PC is the client side of the connection. So we're going to look for both ranges. To look for the server side, we're going to use a simple resource called GRC Shields Up. And we're going to enter in Google this search term, and you'll notice Shields Up is one word, and we're going to select Internet Vulnerability Profiling. We'll click Proceed. And when this screen comes up, you'll notice that there are some very thin silver buttons with options. They're kind of hard to distinguish, but these are actually separate buttons. You're going to choose the one in the middle on the top, All Service Ports. And this is going to provide us with the server side 0 to 1,000 ports. So this is going to identify the ports that are connection ready in a sense. And you'll notice that everything is supposed to be all green. In this case, the firewall for the laptop or PC, or perhaps the firewall for the wireless access router, is not shielding the blue ports. And that can indicate either previous sockets, or it could indicate the intention to connect on these ports for future access, whether it's unwarranted or planned. And so what you see here, everything should be green. What you see here, you never want to see red, but everything's blue here. And it's kind of hard to get each of the port numbers by mousing over this, because that takes some time. There's a really nice feature here called a text summary. And what you'd want to do is click Text Summary and then copy and paste into a text file on a temp folder. And that's what I'm going to do. I'm going to copy and paste, and then I have a text file in Notepad ready on my temp directory. I'll copy and paste this. These are the server-side ports that are connection ready. The ports are closed, but there could be something that's ready to fire off. Maybe it's waiting for an event to trigger. What we want to do is take a look at what's going on in terms of activity on our system, look at the services, and then investigate which ports these are involved with. I'm going to save that. I'm also going to run a command called Netstat in a command prompt that's running in administrative mode. So I'm going to run as administrator, and I'm going to copy and paste this command and save it to that same temp folder on the C drive. So I'll click into the window here and then right click with my mouse. Let's try that again. Or just type it because it's being stubborn. Netstat -A. And then I'm going to redirect the output to a temp folder, text file. I'll call it netstat.txt. I'll hit enter again. There's something about Netstat on some Windows 10 machines or Windows Servers machines where it just seems to hang in this mode where it's always It seems like it's always running, but it's actually finished by pressing the Enter key twice. As soon as the command is finished running, you'll get another command prompt. So another thing we're going to do is determine the IP address for my PC or laptop. I can do that by opening another command prompt, run as admin, or even if I don't run as admin, I'm just going to type in ipconfig, and I want to determine the IP address. This is the reference point that I'm going to use once my Netstat results have been collected. I want to eliminate all of the Netstat references collected for other network interfaces that aren't connected. I have virtual machines with network interfaces. I have an Ethernet port that's not really connected. I have IPv6 interfaces. I'm not interested in any of that. But the active IP address locally is 192.168.1.11. That's my interest here. So I have my Netstat results. I'm going to navigate to my temp folder and open my Netstat results. And on this side, I'm going to be interested in the higher numbered ports associated with my active network. And you see here, closed but waiting. This is similar to the results that you see for GRC shields up on the server side. So these higher level ports are likely to be client-side ports instead of, even though they're not a 5-digit number, we're interested in those ports to see what's going on. And you see Netstat-A gives us some details about the connection on the other side. We have some connections that are in progress right now. We already know about the GRC connections, so we could eliminate those. I'm gonna clip those out. I'm also going to clip out anything that has nothing to do with 192.168.1.11. So I'm going to surgically remove anything that has nothing to do with 1.11. It's interesting that we have loopback listening on TCP/IP. I'd like to know if that's standard. But I'm going to go ahead and call this out just to clean it up. I'll leave loopback because loopback also includes any of the active ports. So here you have the listing, and again, we're interested in anything that's actively listening or anything that's closed and waiting on the client side of a socket connection. So between the two text files, we have information about how your laptop or PC might be ready for a connection or active for a connection, either as a server or as a client. We can take this information and then use it to start investigating further with Wireshark or with sysinternals. There's additional information you can get by using NetSH and show neighbors. That's an interesting command. In any case, these are the two data files that we want to save and submit for work later. This concludes our review of GRC and Netstat. Thank you for joining us. We'll have follow-on sessions that take things to the next level. Stay tuned.